Boyle's Law. Boyle's Law simply states that the volume of a confined gas at a fixed temperature is inversely proportional to the pressure exerted on the gas. Example of Boyle's Law. When the pressure around a balloon increases, the volume of the balloon decreases. And likewise, when you decrease the pressure around a balloon, its volume will increase. Example, you could take a balloon and take it into outer space, and the balloon will expand. Boyle's Law formula. P1 times V1 equals P2 times V2. This is the form of the law that you should memorize. Here is an example problem. This would be a typical type problem that you would want to look at. Sulfur dioxide, SO2 gas, is a component of car exhaust and power plant discharge, and it plays a major role in the formation of acid rain. Consider a 3.0 liter sample of gaseous SO2 at a pressure of 1.0 atmosphere. If the pressure is changed to 1.5 atmospheres at a constant temperature, what will be the new volume of gas? One way to approach these types of problems, first of all, is figure out what is fluff and what is not. Well, the blue part of this is fluff. It's information that is added that doesn't help or hinder your problem. Then the next part is that you want to do is go and figure out what parts of the problem are given, pressures and volumes. As I switch to a pointer, my pointer to a pen, we'll underline some things that you'll want to be aware of. So first of all, we need the formula. P1 times V1 equals P2 times V2. And here we want to figure out which is P1, V1, P2, V2. So here we have 3.0 liter. This is a volume, the volume of the gas. This here is an atmosphere, so that has to do with pressure. So this would be V1, this would be P1. If the pressure is changed to 1.5 atmospheres, so this is a pressure, so this would be P2, at a constant temperature, what will be the new volume? So we're going to be looking for V2. Next slide, we will show you how to set it up. Explanation. Here is the formula, P1, V1 equals P2 times V2. We're going to take the numbers that we had underlined and put them in the proper spots. So the P1 number was 1.0 atmospheres and the V1 volume was 3.0 liters. The P2 atmosphere was 1.5, and we are looking for the V2. Now what we are going to do is we are going to solve for V2. So in the process of doing that, we are going to divide through this side by 1.5 atmospheres, ATM. And we need to do the same thing to the other side. We get 1.5 atmospheres on this side. The atmospheres will cancel out. We are left with volume on this side, and we can cancel out on this side the atmospheres. That gives us what we're looking for in units. So now all we have to do is do the math. And when we do the math, we end up with the V2 equals 2.0 liters. So, does this answer make sense? This answer makes sense according to Boyle's law. As the pressure of the system increased, the volume should have decreased, and it did. So here's the volume 2, this is volume 1, so 2 is less than 1, so the pressure decreased as we increased the pressure. On this slide, we are looking at Boyle's law being graphed out. It is an inverse proportion. So what we have here is the graph showing an inverse proportion. So as the volume goes up, the pressure goes down. Or as the pressure goes down, the volume will go up. So when you graph an inverse proportion, you get a curved line similar to this. What you need to be aware of on this is that this is volume, and this is pressure. Because you will be doing problems and or have questions on the test that will ask you to graph Boyle's law and some of the other gas laws that we look at. So you do need to know where the pressure and the volume are on the Boyle's law graph.